To help you understand how the technology of OpenShift virtualization can assist your engineering teams, your development teams, your infrastructure teams to deliver what you require in terms of value, the applications that your customers need to use, how you can get those out there, and how we can help you with OpenShift virtualization to allow you to land the workload in the right location at the right time based on your requirements. This cluster is running on Red Hat OpenShift on AWS. And on top of that, we've installed Advanced Cluster Manager. This provides your engineering teams, your infrastructure teams with the single pane of glass that gives them full visibility to their hybrid deployments. We are utilizing the cloud for this example simply because we can stand up servers there easier. This allows us to connect through. ACM, like I said, is that single pane of glass. You jump into here and you can immediately see the number of clusters that we've got. Like I said, this ACM is running on top of Red Hat OpenShift on AWS or ROSA. We also have another ROSA cluster. We also have an Azure Red Hat OpenShift cluster in Azure, and we also have an OpenShift dedicated running in Google. If you take a look what we have, you can see the clusters that we have in total, the versions that they're running on, the application types that are there. Are there any violations? No. Work accounts and all of that. Like I said, this is to speed up and to give the visibility to your engineering teams what they need to see straight away. As you would expect, it doesn't just allow you this high-level overview, but you have the ability to dig in, add more clusters, remove clusters, configure clusters, and things like that. We'll jump in and we'll take a quick look. Obviously, this dashboard now segregates out each cluster as it is there. See, there's an important bits on the top where you've got cluster lists, cluster set, cluster pools, and discovered clusters. And you have the ability to create a cluster or import clusters that you've already stood up else. We'll quickly jump into the ARO cluster. As you can see, the amount of information, things like labels, what version it's on, and all of that is here. You can also set the ability, the channels that your cluster is looking at, the ability to upgrade them and move them around to the versions that you want, and also initialize the actual upgrade should you want to. If we click on nodes, that gives you all of the virtual machines that are required to actually run the environment here. If you click onto one of those nodes, it'll immediately take you through to the cluster console. We'll just take a quick look at cluster sets. Cluster sets, like I said, allow you to define the boundaries around groups of clusters or stick clusters together in a group. In our case, we're looking at multi-cloud because that's what we're demonstrating, but this could be your production, non-production, pre-production environments, or your specialist AI environments, however you want to segregate them, however makes sense in the way that you want to apply controls and policies. If you click into your cluster set, it immediately brings up the list of clusters that are there, another high-level overview, cluster lists, your cluster pools, but more importantly, it pops up this something called Submariner add-ons. The way that we allow these clusters to communicate is through the utilization of Submariner. Submariner sets up IPsec VPN tunnels between the cluster that can expose the whole cluster down through services down to pod level. And obviously it's set up through IPsec because of the levels of security, but also the bandwidth that's required. So once again, allowing your teams to do what they need to do with the comfort of not be concerned about security as a whole because it has been implemented for you as you would expect from Red Hat. Those two important buttons I mentioned, you need clusters to make it worthwhile having a cluster manager. We allow you to stand up clusters beforehand and then you can import them in. There are multiple ways to import them in manually or using the cluster API and the token. We also allow you to build clusters directly through this interface as well. And as you can see, there are a plethora of places Once again, truly hybrid. You want to deploy it in AWS, you want to deploy it in ARO, you maybe even want to deploy it on OpenShift virtualization that runs on-prem. ACM brings you that opportunity, and we will work across all of those environments to deliver the applications, the virtual machines that you need to run. We'll quickly jump into the governance area. As mentioned, the ability for consistency and control over the clusters is very important, and this is where you can set that. One of the best ways to run environments these days is through GitOps, and we have the OpenShift GitOps operator. Now, for us to be able to demonstrate what we're going to do today, we need to install that. But just like any other operator, or just like any other control you need to put in place, the governance and the policies are where you do that. We've defined that we want the GitOps operator to be installed on all of the clusters that we're using here. And you can define many different policies, and we'll demonstrate very shortly that there are templates there already for core things that we see customers use day in, day out. But if we just click through to the GitOps operator installation, you can see even more information down there. It comes with the steps that were required to implement the need, or to install the GitOps operator, the messages that get brought back, but more importantly, as you can see, if there are any violations, they get highlighted very quickly. We'll jump into creating policies, and as you can see, once again, it's very much a form-based element, but as you click through, and as I just mentioned, is that you've got policy templates that are there and available directly out of the box for you to be able to use. Important things like enabling etcd encryption, to install the operators, to remove privileged pods so nothing runs as root, that role bindings must exist, and these will get pushed out to all of the clusters that are under this policy. We'll jump now to the application section. As you can see, there's a number of applications already installed. But if we click on the create application, you'll see this is where the importance of Argo CD comes in, where you have the choice to how you would deploy your application. Pull model is the better choice for security because it pulls it in from a repo, and as an engineer I talk about security where people shouldn't have to touch production because you've implemented these processes, you've built everything, it's infrastructure as code, it's applications as code, and you get to the point where you've marked off your repo and your containers in such a way that Argo CD can pick those up where needed in production, saving any human from having to interact with those environments. So as you can see, once again, form driven, or you could implement the YAML yourself. We'll fill in the name that we want for the application set here, the Argo server that we're going to use, the time that we're willing to allow to set it up, and then we'll click Git because we don't want to use Helm, but we've got a repo already set up, and anybody that's utilized K8s in the past and OpenShift will know that this is just your bog standard GitOps practice. There is nothing here that we're doing any different that we would do for a container, yet we are deploying virtual machines and we're going to deploy them across the cluster. We'll fill in our sync policy. As I mentioned earlier, this is the way to make sure that you can deliver new VMs into your production environment, but you don't necessarily need to allow users to have direct access to that production environment. Here's the code just to prove it there. So it's a bunch of YAML files as we normally expect, but it is deploying our virtual machines instead of just the normal containers. But once again, VMs run within the containers. So we jump back in. We move on to the placement. We're going to select our multi-cloud cluster set that we talked about earlier. So as you know, this runs across AWS, Azure and Google Cloud. You can set which ones you want to miss on, and we do not want it to run on the local cluster because the local cluster is still part of the multi-cloud bit, but we want it to run on the 3 others. So we do that, we hit next. As you can see, the review comes up and we hit the button. Let's confirm. Let's see what's happening in the background. So we'll dig into our cluster. We'll get the project namespace. We'll move into that. And we'll copy this across all 3 clusters that are running, so we can check that everything is consistent across all 3. Then we get the VM name, we check that's running. We'll get the pod just to prove that the pod is here. And let's get the service, because it's the service that we want to talk to be able to check that these machines are up and running correctly. So now we've got our external IP for each machine. Let's quickly jump in just to confirm that they've actually stood up based on the template we've got, and we're getting the information out of them that we need. As you can see, ISP is telling us that it's Microsoft, so therefore it's running on Azure, as you would expect. We'll jump into the next cluster, and there you go. As you can see, it's saying Google, how long it's been running for, RAM, CPU, once again. And then finally, we'll jump into Amazon. And as you can see, the ISP is Amazon. So there you go. You can see that utilizing the GitOps practices, we have been able to deploy virtual machines, the same virtual machine, across all environments. So we've proven the fact that you can stand up 3 machines very quickly. But you might be thinking, what value does that bring? Just give you a quick example here. You can obviously configure your networking then to be able to connect back to each of the instances from a single URL. And as you can see here, just by refreshing this page numerous times, it will pop up with the different machines running in the back end, therefore allowing you to be able to span all 3 clouds in this case, but deliver exactly the same application that you need to. A quick change to a new view, fleet virtualization. Obviously, virtualization has been around for some time, and the interface that virtualization admins have had available to them has been pretty much the same for a very long time. Red Hat has focused on and emphasized the ability for an easy transfer over for them to be able to use virtualization within Red Hat OpenShift. If you open the Fleet Virtualization interface, you will see how very similar it is to previous virtualization vendors, and where the clusters sit and all the different clusters you have and what is actually running in terms of virtual machines or stopped or paused or errored out across those clusters. And you are able to dig into each cluster individually to see where your virtual machines are sitting. As you can see through this interface, we have 3 different virtual machines, one on each of the hyperscaler clusters that we've got. Just to give you an idea, here is the one from Azure, here is the one from Google, and here is the one in AWS. We'll jump back in now, and we'll just pick the one that's currently based in Google, the OpenShift dedicated cluster. And if we right click on the 3 dots, you can see that it gives us a number of options, one of which is live migration. Migration brings us the choice of do you want to go to a different node within your cluster? But more excitingly, as you can see here, it gives you the option, once again, hybrid capability to migrate to a different cluster in a different location. And we're going to demonstrate lifting the VM from Google OpenShift and moving it across into Azure. As you can see, it quickly maps out all of the information that's required. So network mapping, storage mapping, compute, version capability, and you quickly hit the migrate button and it creates the migration plan. The migration plan is what enables the service to move live. As you can see, it's already at 33%. There's lots of details, the YAML in here, and all of that kind of information that you can see to see where it's going. Currently initialize, prepare the target, and it is moving across as we speak. We'll jump back in and have a watch to see what is happening to the VMs, and you can see that at this moment in time, it is still running in GCP, as you would expect. but it is waiting to get the migration connection in Azure. And then it immediately flips to the status of migrating. It will copy across the data that will allow it to be able to run in the new cluster. Depending upon the size of the VM can dictate how long this takes to migrate. As you can see, it took about 80 something seconds for it to be migrated across, for the data to be migrated across, and for the system to come up. It didn't immediately kill the instance in GCP because it had to check that the new virtual machine was up and running. But then as soon as it did, it was migrated, data and all, into the ARO cluster. As you can see, one is now stopped, whereas the same name is now up and running in a different cluster. We, in the browser, jump to a new IP address, the new IP address of this virtual machine, and you can now see that it is running on Azure, and that matches the IP address there, but it's still got the message that this was the cloud VM that was deployed on OpenShift dedicated in Google. The great thing about that live migration technology is it allows you to bring in your virtual machines from other environments. The key bit being that you want to make your moving away from other hypervisors as easy as possible. So we're going to take you through a quick example where we're going to migrate a machine off of VMware and move it into OpenShift using exactly the same technology. So we'll pick the cluster that we want to migrate. So now we know what it is, and then we'll jump back into the OpenShift console and we'll click creating a plan. As you saw, when you do the live migration, it created the plan automatically for you. We're going to do exactly the same here in this process. You fill in the information, so you have to put the input details of the virtual machine source, in this case vSphere, and where you want it to land on the OpenShift cluster, or whichever OpenShift cluster that you want it to land on, and also within the project namespace that you want it to go to. Once you've hooked in, it'll ask you which virtual machine do you want to migrate, so you can filter that by name, and it will then come up with the virtual machine that you want. Set up your networking. Work out your storage, where you want it to get from, where you want it to get to, and the secret that you need to get access, and then the type of migration you want to do. Cold migration is obviously one of the best because it will turn off the actual virtual machine and then make the copy and turn it back on, meaning that you will get exactly the same information on the other side. Review the information and click create. Just like we saw last time, you get the migration plan that's created, and that will bring all of the information together for the migration. And in this case, you can just click start to kick it off. Once again, you can track the migration progress and see what is happening within the cluster itself. And wait for the machine to become available. And there you go. As easy as the live migration, we have now lifted a virtual machine directly from vSphere and moved it onto OpenShift Virtualization, demonstrating how quickly it is for your teams to move away from your current hypervisor and land on OpenShift and manage it on OpenShift moving forward.